This is 8.8, solving radical equations. Today we're going to solve radical equations for the variable x. Sometimes we'll have cube roots, sometimes we'll have square roots, and the thought process is to solve by undoing. So here's our first example. We want to solve this equation for x. So we want to undo pieces. So the first example is 2 square root of x plus 5 equals 8. The first thing we want to undo is that 2. What the 2 is doing to the square root, it is multiplying it. So to undo it, we're going to divide. So what happens is those 2's will cancel, and then we're left with the square root of x plus 5, and then 8 divided by 2 is 4. Now we're going to square both sides to undo the square root. So when I square both sides, I must do it to both sides. So to square root and square, I'm left with x plus 5 on the left, and then 4 times 4 is 16. The last thing we undo is that plus 5. To undo the plus 5, we would subtract 5. So 16 minus 5 gives us 11. You could substitute 11 back into the original equation to verify your answer. Next example. Let's have you just watch this one. So the first thing we want to do is we want to undo the 3. So to undo the 3, we want to divide by 3. And let's clean up the right side. So 6 divided by 3 is 2. Now we need to undo the radical. So we're going to square both sides. So square root and a squared, we get 2x minus 1. And then on the right side, 2 times 2 is 4. The next thing is to undo the minus 1. So we're going to add 1 to both sides. And the last step, divide by 2. 5 divided by 2 is 2.5. This example, I do want you to write down. Now we're talking cube roots. So we want to undo cube roots. So to undo a cube root, we cube both sides. So x minus 5, cube root, we're going to cube it. Again, do the same thing on the right side. Cube it. And what happens is the cube roots and cubes cancel each other out. So we're left with x minus 5 equaling 7 minus x. Now we solve this linear equation for x by combining like terms. So I'm going to add an x to both sides to cancel the x's on the right. And then x plus x is 2x. And the next thing I'll do is add 5. 7 plus 5 is 12. And then divide by 2. And we get 12 divided by 2 is 6. Next one. Write this one down. It's a little bit different. You don't want to go ahead and square both sides quite yet because of that plus 3. So let's bring that plus 3 over to the right. Now we can go ahead and square both sides to cancel out the square root. So we just squared both sides. Now the left side, the square root and the squared will cancel out. So we have x plus 1. On the right side, we have 2x plus 3, and then another 2x plus 3, and we're trying to find out what x is. So what we have to do is we have to FOIL this right side. by those two parentheses together. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. 3 times 3 is 9. Now what happened is a quadratic equation popped up. So we want to convert that to standard form. So we need to bring all the terms to the right. So I'm just going to continue with the right side and combining my like terms on the right. So 6x and 6x is 12x. And then set it equal to 0. Bring the x and the 1 to the right. So I'm going to subtract an x and subtract 1. Now combine like terms. 4x squared. And then 12x minus x is 11x. And then 9 minus 1 is 8. Now you try and factor it and set those factors equal to 0. And if you can factor it, then use the quadratic formula. This problem is not factorable, so we have to use the quadratic formula. So this should be a nice review for you. So you identify the A, the B, and the C, and then you plug it into the quadratic formula. X equals negative B plus or minus B squared minus 4AC all over 2A. And now you need to simplify that equation for x to find your x. So x equals negative 11 plus or minus, and then 11 times 11 is 121. And then negative 4 times 4 times 8 is 128. And then 2 times 4 is 8. Now we reduce the radical. 121 minus 8 is negative 7. An issue pops up. If you remember back from earlier this school year, what happens when you have a negative? That's considered a complex solution because of that negative. So we say in this case, no solution possible because of that negative radical. This is our last example. Oh, we have two. I think I'll stop the recording here and then pick up on the last video for the last two examples.